Okay, thank you so much for listening to my presentation. My name is Jessica Kobsa, and I have been a senior fellow this past school year. The title of the project that I've been working on since the summer term is Piloting an At-Home Sustained Attention Training to Reduce Attention to Peripheral Food Cues. Now I know that's kind of a mouthful, so you can see I've color-coded the title and the subtitle. The subtitle is a little bit more of a general term. So basically, my project was evaluating a psychological intervention to reduce a likely cognitive risk factor for overweight and obesity in children and adolescents. So as justification for my project, food cues abound in our environment. On the top half of the slide, I've included just a sampling of examples of peripheral food cues that, just like all the ones that we all see in our daily environments. In this project, I was interested in peripheral food cues. Peripheral food cues are pictures of food that we see in our daily environment that we may or may not pay attention to. Examples are pictures of food on billboards as you're driving down the highway, food and banner ads as you're browsing the internet, pictures of food on magazine ads, newspaper ads, TV, and of course when you walk into a supermarket and there are tons of food pictures all over the place. Those are all peripheral food cues that we attend to in our environment. Research suggests that children and adolescents are more affected by these because they're a little bit less inhibited, their behavior is less regulated, so they're less likely to consciously control their behavior. And importantly, previous research has shown that the more attention children and adolescents pay to peripheral food cues, like what they may see around them in their daily environment, the more likely they are to eat in response to those external cues. We call eating in response to external cues cued eating, and it's as opposed to homeostatic eating, which is eating in response to the internal cues of hunger and fullness. As you can imagine, the cued eating, when you're cued eating, is more likely to you're more likely to eat when you're not in response to external cues, when you're past the point that you're full. So you're more likely. So cued eating is often eating when you're not really hungry. And as you can imagine, over time, cued eating can lead to unhealthy weight gain and even the development of overweight and obesity, which is the public health justification for why we're doing this project. So basically, in this project, in my senior fellowship project, I was evaluating a psychological intervention to reduce attention to peripheral food cues. Hopefully, with the application that could reduce cued eating and reduce this cognitive contributor to obesity and overweight. So briefly, my methods are summarized on this slide. Drawing your attention first to the diagram on the left. That's my experimental design. And looking at the first box, the yellow box, the first step of this experiment was we had participants, adolescents ages 13 to 17, come into the lab as part of a previous but similar study, and that's where we took their baseline assessment of attention to peripheral cues, and we took additional measurements of their attention to peripheral cues throughout the experiment. So we had a baseline so we could understand what they were before they started the experiment. So the way we measured attention to peripheral cues was using this Tetris game. So if you look to the upper right of the slide, you see Tetris game that we used. So basically, participants would sit down at a computer. We asked them to play Tetris, and you can see the Tetris game box in the middle of the game screen. But also on the sides on either side of the Tetris game box, you can see we had a picture of a food item and a picture of an animal. And we used eye tracking to assess how often and when and for how long participants looked at those sidebars, if they did. Specifically, we use these two eye tracking metrics to quantify this. Initial gaze duration is the average duration of the first fixation to a cue. So the first time they looked at the food item, how long will they spend looking at it? And second, an initial gaze duration reflects the strength of the stimulus or the cue to attract the participant's attention at first. And the second metric we used was cumulative gaze duration, which is the total duration of all the fixations or cues. So the total duration of all the time the participant looked at a food item during the Tetris game. And that reflects the strength of the stimulus to hold the viewer's attention throughout the time of the Tetris game. All right, and so that was how we assess attention to peripheral cues. Going back to the experimental design, as part of this, starting with the lab visits for this particular experiment, lab visit 1, participants would come in, we would show them how to do the tasks we'd ask them to do at home. So the first lab visit was just how do you do these things. Then participants went home, we lent them a laptop, and we asked them to do 7 30-minute sessions of a training while they were at home. Because we were evaluating the effectiveness of the sustained attention training, the real training, we asked half participants to do that real training and half did a fake training that we call a sham training. And I have some videos of what the actual training tasks look like. So people in the sham condition, they just did this. So they had an instruction screen, and then they would see blue dots on the screen. And they would just, whenever they saw a blue dot, they would just click the left mouse button. So blue dot, click. Blue dot, click. Right? And this we designed to not affect attention at all, because it just requires people to respond every time they see a dot on the screen. Whereas people in the sustained attention condition, their tasks looked like this. So they had a similar instruction screen. So they would see yellow dots or blue dots, yellow and blue dots. And every time they saw a blue dot, they were instructed to click. Every time they saw a yellow dot, they were instructed to not do anything. So they'd click, nothing, and so on. So they would click when they saw blue, nothing when they saw yellow. And that, we designed that task to train their attention, because it forces them to look on the screen consistently, right? Because the dots appear so briefly that if you look away for a second, you may miss a dot. And also, because there are two different colors of dots and they have to respond based on the color of the dot. They have two different task sets, so it requires them to filter out the information they need and respond according only to the color of the dot. All right, and then so that was the at-home part. And then lastly, for the second lab visit, we had them come back to the lab. They had a snack to control for hunger, and then they would play Tetris, to assess attention to peripheral cues a second time. Then they did a sham task, or they did a refresher task, which is a briefer version of these at-home trainings, the sham and sustained attention trainings. And lastly, they would play Tetris to assess attention to peripheral cues a third and final time. Moving on, so the conclusions we drew from this experiment were that we had very high completion, very high compliance with the at-home training parts. We had 86% of participants complete all 7 of their at-home trainings. That's across both conditions. And we had about 98% of people complete 5 to 7 trainings, which is very high compliance, higher than I thought we would get. So this indicates other procedural experience we gained was that we had very high participant interest, which was very promising. We developed and deployed an efficient in-lab training procedure. So in only 30 minutes, in only a 30-minute first lab visit, we trained people how to do the at-home tasks, and the high compliance rate shows high rates of understanding of those instructions. We also had high rate of completion and a few problems with the at-home tasks, which are all very promising and support the feasibility of the design and pilot and high acceptability of this task to adolescents, which is very important. This is with a pilot study, where in a pilot study we primarily are looking to kind of smooth out the procedural design. As far as our aims in the statistics, we found limited statistical significance in our results, but that was expected because we had an underpowered study. Our sample size was smaller, and that was just a constraint that we had based on funding and time. But our beta values, which is a measure of effect size, were negative, which is in the hypothesized direction, so that supports the hypothesis that the sustained attention training did reduce persistent attention to peripheral food cues from the baseline to the second measurement. And beta values were also large and comparable to effect sizes seen in other similar research designs, which is also very promising. So we hope that we can follow up the study with a larger study, and hopefully we'll find an effect. So in conclusion, we hope the study will contribute to the development of a convenient training to reduce attention to peripheral food cues, which is a cognitive contributor to acute eating and a likely risk factor for overweight and obesity. So that was my project. So moving on to the senior fellowship as a whole, I was really happy to be able to complete the senior fellowship. I'm very grateful to receive this support and funding. The senior fellowship really allowed me to be the architect of my own education. It gave me time, flexibility, and funding to pursue this large project. It really gave me a chance to follow my curiosity, which I am very grateful for. It also gave me a chance to truly be the pilot of a full year of my education, even more so than, even though we have flexibility in choosing our major and choosing our classes and our extracurricular activities, I really enjoyed kind of being the person to set my own curriculum, my own syllabus, so to speak. It also gave me a chance to challenge myself, to grow and to push my own boundaries as a scholar in ways that I don't think I would have been able to do had I taken classes. The biggest learning moment by far during my senior fellowship was every single time something didn't go the way I thought it would, and I had to improvise or find a solution on my own when I used to have help. So overall, I feel more competent and confident now as an independent learner and thinker than I did when I started this project. My advice to others considering the fellowship would be, I think you're more prepared than you think you are. Trust in your ability to learn, because if your experience is anything like mine, you'll encounter a lot of problems and a lot of questions you don't know how to answer. But I think, at least for myself, I have been surprised by how much I was able to learn on my own. I wasn't sure I would be able to learn that much, but I kind of surprised myself with how I could learn amidst all these questions. So I think trusting your ability to learn would be my advice. And I also would say be prepared to face uncertainty daily, because I think when you're doing a project that hasn't been done before, there is uncertainty. You don't know how things will turn out. You don't know how things will work out. So you kind of just I kind of learned personally. I learned kind of not to be afraid of that uncertainty, and I found that to be really helpful. I think kind of a life skill. My other piece of advice would be to find a way to organize your thoughts or your to-do list if you are doing a big project like this, because I think your thoughts and your to-do list will get long, and it's really nice to have those organized in some way. Also, I would advise people looking into the senior fellowship to make sure that your project is one you're motivated to work on every day without constant deadlines, because the senior fellowship gives you a lot of flexibility and you won't always have constant deadlines. So it's really important to be able to kind of be excited about your project so that you're willing and excited to work on it every day. And lastly, get used to things not always going right in the first try. Be persistent. It sounds cliche, but I think I've learned that during the senior fellowship, that things won't always go right, and you could give up, but I think oftentimes if you try a little bit long, try a little bit harder, I think, it will work out in the end.